distilled at 200 degrees Celsius in order to recover 80% of oxylene. Determine the operating pressure, mole percent of the feed that is distilled, percent purity of benzene in the distillate, and split ratio of toluene. So, the given for the problem is an equimolar liquid mixture of benzene, toluene, and oxylene. We are given the temperature of 200 degrees Celsius and a percent recovery of oxylene, which is 80%. The required for this problem are the operating pressure, percent F, percent purity, and split ratio of toluene. So, to start the solution, we'll have a basis of 200 moles of feed. First thing to do is to find or to get the partial pressure of benzene, toluene, and oxylene in 200 degrees Celsius. We are doing this to help us assume a total pressure. I will also be listing the equation that I will be using. The summation of xli is equals to 1, but xli is equals to xfx over 1 plus f times ki minus 1. Ki is equals to ps partial pressure over total pressure. So first trial, the assumption is the average of the three partial pressures. So we are given the xf's of benzene, toluene, and oxylene, which is 1/3, 1/3, and 1/3. Having total pressure, we can now solve for the ki. Using the summation of xli is equals to 1 that I wrote on the previous something. We can solve for f, and using this f, we can now solve the xli. So to solve for xti, it is the product of ki and xli. To know if the assumption is correct, the summation of xti should equals to 1. If not, you can do other trials to have a summation of 1. Then if for the second trial, I assume a lower total pressure to have a higher summation of the xti. So as I done earlier, first you can solve for ki, then solve for f, then solve for xli, then you can solve for xdi, then you can now have the summation of xdi. So for the final trial, I assumed a much lower total pressure, which is 630,000 Pascal. So finally, I have a summation of XDI is equals to 1. So the assumption is correct that operating pressure is 630,000 pascals. To solve for P percent F, we have percent PRX equals to LXLX over FXFX. So we can solve for L because other than L we have all the given. Then solve for D using the overall balance F equals LD. Then F is equals to D over F. So times 100, you can have now the percent F, which is 53.24%. Next, the percent purity of benzene in the distillate. So percent purity is equals to the composition over the total times 100. So percent 3379 over 1.001 times 100 is equals to 33.79%. So for a split ratio of toluene, split ratio is equals to the composition in the distillate over the composition in the bottoms. So we will have a ratio of 1.1907.